All right, let's look at the homework 2.8, problem number 10. All right, so we have this function f of t equals cube root of t, and we want to find f prime of a. So let's do that. All right, so remember the definition? So we want to find f prime of a is equal to limit as h approaches 0. Right? Then we have f of a plus h. So we're going to put a plus h instead of t. So it's a cube root of a plus h minus cube root. So f of a is cube root of a all over h. Right? And this is a useful equation. So if you have a minus b, sorry, I'm using a and b. This is different from a that I'm using here. But the a minus b times a squared plus ab plus b squared, right? This is going to come out to be a cubed minus b cubed, right? So I'm going to use this trick here. Alright, so as h approaches 0, obviously the numerator and denominator both go to 0. So we're going to have to do something. So think of this as a here and a minus b here. So I'm going to multiply by a squared plus ab plus b squared. So I'm going to multiply by... Alright, so this is going to look a little bit yucky here. So you have first guy squared. So it's a cube root of a plus b squared plus cube root of a plus, a plus b, sorry, I messed that up, a plus h squared plus cube root of a plus h times cube root of a, alright, plus and cube root of a squared. Alright, I'm going to have to put exactly the same thing, so I'm going to actually just do a trick here. So I'm going to just make a copy of this, right? So let's see, I hope I know how to do this, and here. Alright, then I'm going to put it down here. Alright, so it's exactly the same thing. Alright, so this is going to come out to be, alright, so you have a limit as h approaches 0. Alright, so it looks very yucky, but if you multiply this out, alright, so you're going to get a cubed minus b cubed. Alright, so this guy cubed, the cube root is gone, so you're going to get a plus h minus b cubed. So cube root is gone, so it's minus a. So the numerator is really nice. And the denominator looks pretty bad, so I'm just going to copy that thing in there. So here, so that's just, I'm too lazy to write that, so we have that. Alright, but here's the good thing, right? We can cancel a minus a here, right? Then you have h over h, so you have common factor on top and bottom, so you have actually 1 on top. Right? Then as h goes to 0, right? Then you can see that here, right? This guy right here, since h is gone, h is going to 0. So this guy is going to 0. So this is going to cube root of a squared, right? And then here, same thing, so cube root of a times the cube root of a, because this guy basically disappears. So this guy is going to go to cube root of a squared, right? and this guy has nothing to do with h. It's going to stay exactly the same. So you have 3 of the same thing added together. So the limit is going to be, right, so you have a 1 on top and over, right, so you have 3 of them. Then you have a cube root of a squared, right? And if you like that, you can it's fine, or you can write it this way. This is exactly the same thing, 1 over 3, right? A to the, right? So you have to square that, right? So squared, and you have to have a cube root, so it's going to be over 3, right? You can write it that way as well, right? Let's type it in. All right, so we got the 1 over 3 times a to the 2/3 power, right? I don't like those parentheses, so I'm going to try to get rid of that. So here, all right, let's check the answer. All right, it came back, and looks like we got this one correctly. All right, that's it. I hope that this was clear.